This is Algebra 2, Year 2, 7.1, Exponential Growth and Decay Homework, Day 2. The first 6 problems, you have to identify, look at the equation, and determine whether it's a linear function. Linear is a straight line, quadratic is a U-shaped, and exponential is a smooth curve. Yeah. So based on the equations, for linear, both x and y are first degree. So number 1, these are both, remember g of x is just simply y. So when both the x and the y are to the first degree, it's linear. Okay? Next, quadratic. For this one, I would distribute the x, 77x minus x squared. When you have x to the second power and a y value, it's quadratic. Number 3, when you have an x and a y, where the x is where in this problem? Where's the x located? Where's the x located? It's an exponent. This is an example of an exponential problem. Number 4 is also exponential because you have x in the exponent. Number 5, you have x squared, so that's quadratic. And number 6, you have x in the exponent, so that's exponential. I abbreviated some. Okay, number 1, now we're on part 2. Can you identify the parts of an equation? So we talked about this form, a times b to the x power. The a value is called the what? Initial amount. The b is your growth factor. This number is going to be, it's going to be greater than 1 if it's growth, and it's going to be between 0 and 1 if it's decay. So they gave you an equation, and they want you to identify the initial amount and the growth rate. So for this one, the initial amount is your a value, and that is 250. That's your y-intercept. And this is your r value. This whole thing, you have to add them. 1 plus 0.2 is 1.2. So that's going to be an exponential growth problem. Number 2 in the exponential function, y equals 9.8, identify the initial amount and the growth rate. So 9.8 is the initial amount, and this growth rate is 1.35. Number 3, write an exponential growth function to model the situation. A population of 422,000 increases by 12% each year. So the growth function would be y is equal to, the initial amount is 422,000, and you're going to do 1 plus, it's increasing at 12%, and how many years? We can just write x. Now, if you wanted to, how could you simplify this? You can simply add 1 plus 0.12, which is 1.12.
I got a question.
Yes.
How come it says 422,000 0 0? You missing a 0?
Yeah.
There we go.
Thank you. Number 4, write an exponential growth function to model the situation. You start with 30,000 and earn 15% interest each for 25 years. The growth function would be 30,000 times 1 plus 0.15 to the x power. That's equal to your y value. Number 5, a car bought for $13,000 depreciates 12% each year. Write an exponential decay model and then find the value of the car after 5 years. So if it's depreciating, your growth rate is going to be 1 minus r. So it's 1 minus 0.12, which is what? 0.88. That's your r value. So, what's your decay function? Let's use y. We'll stick with y. Y equals your initial amount of 13,000 times 1 minus 0.12 is 0.88 and then to the x power. Now, if they wanted to find out what the value of the car is after 7 years, where are you going to put 7? Right there. So 13,000 times 0.88 to the 7th power gives us, let's type it in our calculator, 13,000 times 0.88 raised to the 7th power is, I have $5,312.78. Anyone have any questions on that? Number 6, if a person takes 8 milligrams of a drug at time 0, then A times 0.7 T gives the concentration level in the bloodstream after T hours. If the initial dose is 125 milligrams, what is the concentration of the drug in the bloodstream after 3 hours? So this is your initial amount. So it'd be, let's use Y again. Y equals 125 is your initial amount times 0.7 times T. That's going to be your decay function. And I probably should have just wrote it here. Now, I want to know how much is in the bloodstream after 3 hours. You're going to put a 3 right here. So what's 125 times 0.7 to the 3rd power? $125 times 0.7 raised to the 3rd power. And there would be 42.86 milligrams. Do you have a question? It's in the way. Now think about it, because the amount of this drug is going down. So does our answer make sense? It started at 125 milligrams, and after 3 hours, there should be less than 125. Next one, number 7. Does the equation 11 times 1.11 model exponential growth or exponential decay?
Growth.
How do you know?
Because it's 1.11.
When the B value, that's your B value, B is greater than 1, it's growth. Now, how do you get 1.11? Well, 1 plus 0.11 is 1.11. So what's your growth factor?
1.11.
The growth factor is 1.11, but the percentage, the R value, is 11%. The growth factor is 1.11, but the percentage is 11%. I want you to be able to do both. Number 8. Does this equation represent exponential growth or decay? It's growth. Why? That's your B value. It's 3/2. 3/2 is the same as 1.5. So it's equal to 1 plus 0.5. So what is the growth factor? It's 50%. It's growing at 50%. Okay, next one. Number 9. Does this equation represent growth or decay? That's your base. Is it growth? Is it bigger than 1 or less than 1? It's decay. Now, find the growth factor. Oh, sorry, I wanted to do this. Exponential decay. Now, how do you get 3/4? What's another name for 3/4?
Yeah.
Isn't it 0.75? Now, how do you get 0.75? And it's 1 minus 0.25. That's how you get your 0.75. So this is decaying at a rate of 25%. Now, if you don't know how to do this, you could also think of it this way. You could do, if this will help you, 1 plus R if it's growth, 1 minus R if it's decay. So if for the one that we just did, if you do this and solve for R, you'll get your 0.25. So if you were to subtract 1, you get negative 0.25 and divide by negative 1. So that would be another way you can do it. I think it's easier just thinking of 1 minus this is your growth rate, or growth or decay factor. Part 3, application problem. We have actually 3 application problems. Number 1, the population of India was 952,108,000 in the year 1996. And it's growing at a rate of 1.3% per year. This is according to the U.S. Census Bureau. Predict the population for 2009. Show your growth function and final answer. So, can someone tell me what the equation is going to be? What's your initial amount? Sorry, there's not a lot of room here. Now, this is your R value. Convert 1.3 to a decimal. It'd be 0.013. So you have to do 1 plus, because we're growing, our population is growing. So 1 plus 0.013 times the t value. How many years, or x? You want to use x and y. X is the number of years. Some people like to use t to represent years. So we have 952 million. And then if you added 1 plus 0.013, you get 1.013. Now, how many years is it from 96 to 2009? Anyone?
From 96?
From 1996 to 2009.
That's the year I was born.
How many years is that?
That's 9.
Well, from 1996 to 2000, how many years is that?
12?
4 years. And then you have another 9.
13.
Yep.
Mine's up there.
So if you put a 13 right here, that's going to give you the population in the year 2009. So what is the population?
13%?
13%.
No, I was just guessing.
The population?
I was guessing.
It's 952,108,000.
108,000.
And then times 1.013 raised to the 13th power.
Equals.
It's going to be a big number. It says 1.12618 E9. That means you're going to take this decimal and move it 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 6, 1. Sorry, guys. 1, 1, 2, 6, 1, 8. Now let's check this out. If the decimal was here, 1, 2, 3, 4, 5, 6, 7, 8, 9.
112 million.
And now we're going to put some commas in here. So it'd be 1,126,180,000 people.
Money.
Okay, next. This formula, you've got it, first of all, you need to know when you're compounding interest, there's 2 formulas. The formulas are, I'll write them here. A equals P times 1 plus R over N to the N times T power. You're gonna use this formula on all of these except for the continuous one.
What's the formula?
It's A equals P times 1, P is your principal, times 1 plus the interest rate in decimal form over the number of times a year. You gotta know what the N value is, and then times the number of years. So you're gonna use this formula for all of these ones right here. Continuously, you use a different formula. It's A equals P times E raised to the RT power. So for these ones, you use A equals P times 1 plus R over N to the N times T power. Now, you've got to know what N is for annually. How many years are there in an annual? 1. 1 year. How about quarterly? How many quarters are there in a year? 4. How about semi-annual? How many semi-annuals are there in a year? 2.
2.
How many months are there in a year? 12. How many days are there in a year?
365.
Okay, so those are the ones you need to know. So now what are you gonna type in here? Your formula, we're taking $1,000. So for this one, it would be 1,000 times 1 plus the interest rate is 6%. You have to convert that to a decimal. And N is 1 for this one. 1 in how many years? 20. So let's type this in our calculator. We have 1,000 times 1.06, and raise that to the 20th power, and you should get $3,207.14. Did anyone get a different answer? Okay, how about quarterly? 1,000 times 1 plus 0.06 over 4, because there's 4, N is 4, and then this is going to be 4 times 20. So we're going to do that one.
Wait, can you move your
1,000.
calculator?
Move my calculator, yep.
I'm good. Thank you.
So what is one, did anyone get this one? 1,000 times 1 plus, I want you to see me type this in the calculator too. It's 6%, 0.06, and then 4. Now, it's up to you on this part. You could do, obviously, 4 times 20 in your head. What is 4 times 20? 80, right? And then hit enter. We have $3,290.66. What about semi-annual? Now let's talk about common sense here. Do you expect this number to be more or less? How should it rank between these two? This is 4 times a year, but this is twice a year. Shouldn't your number, if you're only doing it 2 times a year, fall in between these two? Let's see if we can get that. So we have 1,000 times 1 plus, get my fraction, 0.06 over 2 now, and then raised to the 80 power. Oh, no, wait. I have this is supposed to be a 20.
That's what I was about to ask you too.
So it's 40. I'm like, how could it be the same? That would be 40, and we get $3,262.04. So this makes sense. If you're doing it twice a year versus 4 times a year, but more than once a year, it should be in between, and it is. What about 12 times a year? That should be more than this number. So 1,000, and so should this number. This should be even more than that. 1 plus 0.06 divided by 12, and then 12 times 20. And this one is 1,000 times 1 point,
Can you slow down?
slow down,
That's gonna be big.
okay, are you on Taylor 12? You're on 12? So 1,000 times, and then in parentheses, 1 plus the interest rate, we want a fraction. .06 over 12. Now let's say I don't want to multiply that in my head. Then I can just do 12 times 20. But make sure it's all in the exponent. For this one, I got $3,310.20. And the last one in this category, you're now gonna invest $1,000 daily. So 1,000, now this should be the biggest number. 1 plus, and then our interest rate is .06. We're gonna get interest daily. And now this one I'm gonna do 365 times 20 years. And that is $3,319.79. Now, is it a lot more money? Not, I don't consider $9 a lot more money, but it is more money. Now, if you see the word continuous and not one of these words, you jump into this formula. There is no n value. It's the principal
What's the n though?
times E. The rate is .06 times 20. That's the formula.
This audio.
Yes.
Did you say there is no n?
There is no n for continuous.
So could we put like NA?
So this one's asking you for the n. There is no n value. It's you're using this formula here when it says continuous.
Alright.
So it's 1,000 times, now your E button is right here, right there. So E raised to the .06 times 20 power. That's how it looks when you type it in your calculator. It's 1,000 times E raised to the 6%, it's rate times time. Then hit enter. And there is, that's gonna yield the most amount of money, to $3,320. And 12 cents, I'm sorry. And the last one. Find the effective yield for an initial investment. If we start with $5,300, and after 6 years, this is worth $7,400. Now, I would do this on a calculator. So what are they saying? We want to end up with $7,400. If we start off with $5,300 and we're investing initial investment after 6 years, and we're going to say continuous. E, we don't know the rate. And the T is 6. Now what you could do is T is gonna be 6 years. You can type this in your calculator, just like that. This is 6. Now this R value is really your X. So what I want you to do, we're gonna do this on the calculator. We're gonna type this in under the graphing function. So you're gonna add a graph, and this is the hardest problem. $53,000, or $5,300 times E raised to the, we're gonna call this rate our X value. So it's gonna be 6X. Now, when you hit graph, what I want you to do is go to your table, Control T, and I want you to look for the Y value that is going to give you 7,400. And we're gonna finish this tomorrow. No, we're done.
Click.